Hello, welcome to a screencast on recovery from exercise. So this specific screencast is going to be looking at the moment we stop exercise, what happens within our body that allows us to recover certain things that are depleted when we've kind of took part in exercise. As you can imagine, when you're exercising, it takes its toll on the body. It can deplete our glycogen stores, it can deplete our PC stores, ATP stores. It can have lots of kind of negative effects on our body. And when we stop, there are certain processes that allow us to kind of recover back to our pre-exercise state. So if we have a look at specification, I'll come over to the graph in a second. If we have a look first up then, our first key thing to look at, I suppose, on here will be, this term. And now this term here, how the body returns to its pre-exercise state, is something called EPOC. Now EPOC stands for excess post-exercise oxygen consumption. So really that makes a lot of sense. It's the extra oxygen you get when you stop exercising, but we have to know it as EPOC, so make sure you've got this bit down. Okay, so that's the first component. Now what we have to do, if you look over to here, basically when you start taking, I'll take that off for a second. EPOC then is anything that takes place from the period you stop exercising until the period you fully recovered. So this period here is all EPOC. Now there are two components of EPOC, as you can see up here. Now point A, okay, is the fast component. It's called the alactacid component, or DET, and it's under EPOC. After you get past about 3 minutes, okay, you then kick in and start to use more the lactacid recovery part of EPOC. Okay, so we'll have a look at what they mean in a second. So just to get your idea, first period when you stop exercising, the main recovery system will be the fast one. So it's the first and fast, and then the second one is coming down here, which is the slow component, and that's called the lactacid, but we'll look at that a little bit more later. So fast components of EPOC then, what's the key process that occurs and duration, etc. So that's what you have to know, which you'll have a look at in the screencast in a minute. So what you're looking for then is the key focus of this is replenishing blood and muscle oxygen stores. So getting oxygen back into the kind of components of the blood and muscle that allow us to transport it to where it's needed to go. Also, we need to resynthesize ATP and PC. Now, once this is done, okay, this section here, we move on to the slow component, okay, which is the second component of recovery. And basically, during this component, you look at the kind of fact that when you stop exercising, your heart rate and your breathing rate doesn't just fall straight away. There is still an elevation of your circulatory rate, or your heart rate, or your ventilation rate, or your breathing rate. Now, as well as these things here, but what that means is that it gives us an option to try and get rid of lactic acid, which is down here, okay, so lactate removal and then conversion to glycogen. So we'll have a look at that on the second screencast, and then finally we have to have a look at these things here. So the effect of exercise intensity on EPOC, so how hard we work will dictate how quickly EPOC will work, and then we have to look at the implications of the recovery process, okay, so what do we know about recovery that could help us plan exercise sessions, training sessions, and even matches. So we'll have a look at that as you go through. So that's the kind of key things. We kind of looked at a bit of that on the energy continuum. That's the specification. So ultimately, this whole process of recovery is called EPOC. It's split into two. Fast component is the first one. Slow component is the second one. Then we have a look at some tactics or implications for coaches when they're trying to plan. And you might remember some of that from the energy continuum screencast. So over here, you've got your graph that is going to be linked to. What are we concerned with? We're mainly concerned with this and this. We will have a little bit of a look at this in the lesson, but certainly this and this are the key things to focus on. Now, okay, let's have a look then. Exam questions that have come up from this, so you can kind of see how it would look. So exam questions, this one here. So within the first few minutes following an exercise, explain how the body starts the recovery process. So this will be looking at your first and fast component of recovery, or the alactacid recovery. If you look over to here, a team game such as basketball provides opportunities for recovery from high intensity work both during and after the match. That's your scene setter. And then again, this one goes in to outline the recovery process that occur in the first 3 minutes. And what's interesting with this one is it starts off talking about the recovery process in the first 3 minutes. Then it asks you to use a team game of your choice, evaluate strategies that a player or coach may use to maximize recovery. So that was the bit at the end. And finally, you can see here, this is a 20-mark question on the new specification, the only one that's been so far. It then asked you to evaluate nutritional ergogenic aids that help the recovery process. So this is your synoptic link, being able to link it back to ergogenic aids from the first year. So there's some examples of questions that could come up. The one that isn't on there, of course, there's no reference to the slow component. So you could get a question that just asks you basically, describe the slow component or the lactic acid recovery. So anything after the 3-minute period. Okay, so that's what we'll look at now. So we'll start to take you in. We're going to have a look at the lactic acid recovery, or the fast component of recovery now. So before we do that, let's just get our anything now you want to start making notes. I mean, I suppose these are the key note-taking sections. So when we're looking at this, you've got your section here. You've got recovery graph, you can see here that we've already talked about. Key thing then, if we start basically here, EPOC is used to fuel the 2 recovery systems, okay, making sure we've got that and we know what it is. Then we go down to the next bit. The fast component of EPOC is called the lactic acid recovery, and the slow component of EPOC is called the lactic acid recovery. Now, here it's just a little footnote of the things that kind of deplete as a result of exercise, or the negative aspects of exercise. And then what we'll look at specifically is how these 2 recovery systems, in today's screencast we have a look at how this recovery system can help us replenish things that have kind of depleted during exercise. So let's have a look through. If you can make a note of that, I mean, which order you do it's completely up to you. So during exercise is depletion of this. Okay, and we're going to have a look at how EPOC, or fast component of EPOC, and slow component of EPOC, used to kind of get this stuff back. Okay, let's have a look then. So starting on recovery, first bit then. So fast component of EPOC, let's have a look at what it's talking about. This bit here, point A, fast component, lactic acid recovery. Let's have a look at what it does then. So that's the first thing you have to know. It's the first and fast component of EPOC. Okay, so I've kind of repeated that a few times now. So that is always a good start point, because it's the first time, it's the first kind of component of our recovery. And its key function is to replenish ATP and PC stores. And I always think that works quite nicely, because you're thinking, right, it's the first and fast component of EPOC. And then if I think to you, right, what are the first things that get depleted when you start exercising? Well, the first thing you kind of break down is ATP. And then the second thing you break down is PC. So they're the first 2 things that go, that are depleted. And then you're looking, in a recovery, the first and fast component of EPOC, the key function is to replenish those things that run out first, so ATP and PC. So that gets us in. What is it? First and fast component of EPOC. What's the key function? To replenish ATP and PC stores. Now, how does it do this? Well, it does it via the aerobic system, okay? Because as soon as you stop exercising, you have the excess post-exercise oxygen consumption, e.g. EPOC. That means you're flooding your body with oxygen, which means the aerobic system is predominant, it is working, and it basically allows energy to be produced via endothermic reactions. Now, endothermic reactions, at this point, I mean, if you just stop the screencast, could you remember what an endothermic reaction is? Okay, so you use the E here. So do you remember it was that process of energy being used to fuse smaller elements into larger molecules? So that's what an endothermic reaction is, okay, using energy. So if we're concerned with getting ATP and PC back, we have to have a look at how energy from the aerobic system is used to get these back, because when they're depleted, they're separated. So now what we have to do, so you think if that is gone, it would be down to ADP. If that was going to be down to P plus C. So what you have to do then is use the E on here in an endothermic reaction. So E plus P plus ADP forms ATP. And then same process for synthesizing or replenishing PC stores. Okay, so the E joined to the phosphate or the phosphagen plus the creatine equals phosphocreatine. Okay, and that is used because we have that energy from the aerobic system. Okay, so that's the key thing. So far then we've kind of answered our question of how do we get ATP and PC stores back. So that is how we do it. Aerobic system, endothermic reactions. You need to show you understand what an endothermic reaction is and how it builds back up the things that have depleted during exercise, which is ATP and PC. Okay, so now what happens, and this is a really key bit now. So the excess oxygen referred to in EPOC, okay, that excess post-exercise oxygen consumption is due to the fact that when you stop exercising, your respiratory rate, e.g. your breathing, doesn't fall directly back to its resting rate. Of course it doesn't. It stays elevated. You're still breathing relatively hard for 2-3 minutes, 5-6 minutes sometimes after exercise, and so is your heart rate still kind of elevated. And because of that, this elevation of these two things, this means that we get this excess oxygen. And I suppose the key things you have to quantify now is kind of say, right, so how much oxygen is required for this system? Okay, so what we need is it needs 1 to 4 litres of oxygen to allow us to kind of put the oxygen back into the places we need. So if I said to you, now that's how much of the oxygen you need, and now we need to understand what we actually use that oxygen for. So what do we use the oxygen for? Well, this is what happens. Oxygen is used to bind to hemoglobin and myoglobin. So this extra oxygen, EPOC, 1 to 4 litres of oxygen, binds to hemoglobin and myoglobin, okay, and that then allows us to kind of replenish our blood and muscle oxygen stores via oxyhemoglobin in the blood and oxymyoglobin to the muscles, and they obviously work together. The thing the spec really is interested in is muscle oxygen, so we're talking about myoglobin and oxymyoglobin, but I think it's a process, isn't it? When you breathe in oxygen, okay, when it comes into the bloodstream, it joins hemoglobin to form oxyhemoglobin, and then once it travels from the bloodstream, then we're looking to get it into the muscles via oxymyoglobin. Okay, so I think that's a process, and I think it will help your understanding going back on the specification. Okay, so if you kind of get that process there, hopefully you can see these are our key focuses so far. The final thing you need to know is the time. Okay, so what time does it take for this system to work? Now, if you look back here and say that, you know that kind of the key focus really is getting PC back, you know something about, from the energy continuum, how long it takes to fully recover PC stores, okay, certainly after explosive actions. So this fast alactacid component of EPOC, okay, takes 3 minutes. So 3 minutes to fully, that is usually, if it's been extremely explosive exercise, it will take 3 minutes. Okay, so they are your key things. So I'm hoping you feel like that makes sense to you. So if you go back to the specification here, you can kind of see what you should know by now. So how the body returns to its pre-exercise state, this term EPOC. Then we need to know the fast components of EPOC. So you need to know the replenishment of blood and muscle oxygen stores. Okay, does that make sense? And then, so you've got your hemoglobin, myoglobin, oxyhemoglobin, oxymyoglobin, ATP, PC. How is that done? Okay, endothermic reactions, do we remember that? And hopefully you can see how this key area is done. Now I'm going to go back just quickly onto here. I don't know if you remember me saying at the start, so during exercise there is a depletion of ATP and PC stores. Okay, there's also a complete depletion of glycogen stores. There's also a depletion of oxygen from myoglobin. So what we have looked at in this kind of screencast is how this first and fast component of EPOC, the alactacid recovery system, okay, this is resynthesized, looked at ATP and PC, done. And it's also looked at how we get oxygen back to myoglobin to form oxymyoglobin and allow us to kind of flush our muscles with oxygen. Now, what we haven't looked at is glycogen and lactic acid, and in those two things will form the basis of recovery for the slow component of EPOC, which is known as a lactacid recovery system. The lactacid recovery basically involves removing the accumulated lactic acid or using it to help us recover our body. Okay, so that's the screencast done for now. Hopefully that makes sense. I'll leave it on the spec here if you want to just check you know everything that has come out of this screencast. Thank you.